Hello, I'm calling from the actual place where DIY cell culture is being done. So, and it's also live casted like that on a time lapse video. So that's it's a Shojimi project Shibuya Lab in Fab Cafe Tokyo, and seems like there's an weekly meeting ongoing. Yeah. So I think it's the time where I should go. So Fab Cafe a little bit too crowded for filming a presentation. So I'm come back home to do another one. Um, so today in a CMS21 scaling session, I would like to cover what we have been doing in Japan and the topic of scaling and cover the topic of scaling more from technology point of view based on what we do. So just an introduction. I'm the founder of the Shojin Meat Project, an open source culture meat hobbyist club, and also the founder CEO of IntegriCulture company. I got into the world of cellular agriculture mainly because they appear in science fiction, anime, and manga. Um, so I'm basically fascinated by the roles those works of fiction portray, such as the fluorescent green tubes, manufacturing various living parts, and all other um, and all other sci-fi gadgets. In the early days of the Shojin project, I was discussing with other members on what the world may look like with this technology. Will we see vast land reverted to nature, or will we see the merger of merger of agriculture with manufacturing industry? If we have that technology in place, would we have dystopian future or utopian future? Obviously, we want a utopian, but what would that utopian future of cellular agriculture may look like? Will it have will the technology be democratized? And would we see community bioreactors with people having universal access to the technology? So all sorts of sci-fi dreams being discussed in the early phase of in the early visioneering. But since then, as entire cellular agriculture moved to the delivery phase, things have moved into two streams, one in social and legal infrastructure development, and the other into physical infrastructure development. The social and legal infrastructure development is currently driven by Ministry of Agriculture, Forestry and Fisheries, and it's now quite high on the government agenda. And what's going on there is rulemaking in Japan. So this rulemaking is different from lobbying. That in case of lobbying, it's basically an attempt by a company or trade union to influence the decision of regulators or policymakers. But the rulemaking is more of a society-wide harmonization process where a wider spectrum of stakeholders get involved to start to build rules from wider point of view. With that in mind, IntegriCulture company is building the physical infrastructure and physical infrastructure aspect of cellular agriculture. The company's vision, universally accessible cellular agriculture, inherited from the original vision, and is that all players, including like restaurants, individuals, like artists, or large scale, large food companies, and all should have access to the technology of cellular agriculture. But from technology point of view, we see that there's we are fully aware that there's a big problem. especially with the cost of cell culture. So since 2013, cell cultures got cheaper, but not enough. So how do we break that price floor? And our answer has been the Carnet system, which basically cuts the cost of growth factors to near zero. This Carnet system consists of target cell bioreactor and feeder bioreactors that contain different organ cells inside. As the culture medium circulates through these bioreactors, and the culture medium picks up the metabolites from these organ cells so that the target cell grows. So this is basically, in theory, what's happening in natural systems like cow body or fish body. So this system, by using this system, the user becomes free from the need to buy expensive growth factors from outside, because growth factors are made in situ inside the system. This is another schematic of the Carnet system, which consists of the palette of feeder cells connected with the target cells. So this is a demonstration of the technology. So we're comparing this against DMEM 10% FPS, which is the existing gold standard for cell culture. So if we culture a duck hepatocyte using 10% FPS, we found that the doubling time is about 48 hours. But if we use the cultured serum produced by the Carnet system, it basically cut the doubling time to about 30 hours. The cell grew so much that it quickly hit the confluence where cells cannot proliferate anymore just because there's no room anymore. So this is a picture of Dr. Iko, the CTO of IntegriCulture company, holding a bottle of Carnet serum optimized for duck hepatocyte. When we've analyzed this cultured serum, we found that it contains peptide growth factors, non-peptide growth factors, and the ECM components. More in the this shows things in a more detail. So we have tested different feeder cell combinations, A, B, C, D, E, F, and such. And we found that the composition of the Carnet serum and what growth factors are in there at what concentration, that depends on the choice of feeder cells. And also, multiple feeder cell combinations are effective for avian hepatocyte culture. So we might probably want to choose the best performing feeder cell combination for that. Beyond just cell proliferation, combination of feeder cells can be optimized for purposes other than proliferation. So we could use feeder cell combination for differentiation or organization. That's basically what's being done to produce cell cultured foie gras. So that was the case with foie gras, but obviously this can be applied for other types of cells like beef cells or tuna cells or shrimp cells and such. So as we offer this technology to anyone, we've built a scheme called the Carnet pipeline, which starts with the laboratory scale feasibility and optimization, scaling up to operation and commercial scaling. Through this process, what we do, this describes what we do with a new target cell, which could be lamb, whale, or tiger liver, or bear bladder, or any other random cells, to proliferate or differentiate. So it really depends on the target cell and what we want to do with the target cell. But what we first do is we look at the library of feeder cells and work out the feeder cell combination that induces the desired response for the target cells. And this is done by no magic. It's just empirical brute forcing of finding the best performing combination of feeder cells. And once the combinations are found, a commercial scale on the Carnet system, which is under development, partially funded by the government. This is probably what the client wants, a full-stack cell cultured meat factory. But obviously, this factory contains a whole range of components, including cell culture bags, HVAC, and such. So it's not something that a single company can provide everything. So our answer to that is basically to collaborate. We collaborate with heavy engineering firms for bioreactor systems. We can collaborate with manufacturers, food companies, and such. And that's exactly what we are doing with the Carnet consortium. So right now, 12 entities are disclosed and more are joining by the end of 2021. And it's planning to go global once ready. So some of the member companies here include heavy engineering firms, food companies, manufacturers, bioreactor manufacturers, and such. For example, Chiyoda Corporation on the top left, they used to build petrochemical complexes. But as we decarbonize, the future of such industry is uncertain. So it's reasonable that Chiyoda Corporation gets interested in cellular agriculture facilities. So with them on board, the whole picture of Carnet system infrastructure gradually takes shape. So those cellular agriculture infrastructure component providers can join together to build a cellular agriculture infrastructure. And this infrastructure can be made accessible to the users, that are initially most likely food companies that want to make cell cultured products, but not limited to food. Also has a benefit, especially on the IP side, because the users of the Carnet system can decide what cells to culture in the feeder cell bioreactors. That means if farmers or restaurants or food companies come up with their own IP on the Carnet system, so that they can build their own brand. This scheme basically goes back into the original visions, where how to make it made open and transparent, while the industrial scaling goes into the business domain, so that citizens will be the decision makers, unlike in the case of GMOs. So what we've been doing, starting with the visioneering, the stream has split into infrastructure development and rulemaking. And for the infrastructure part, the Carnet system is developed to answer what's being discussed at the rulemaking roundtable discussions. And both combined, we hope that the initial visions of democratized cellular agriculture becomes a reality by the implementation. So here are the key takeaways. So having one root vision can push forward technical and rulemaking development hand in hand, but democratization of cellular agriculture as the initial vision in reality means lots and lots of onboarding of different stakeholders at a scale. And this onboarding, I think, is another aspect of scaling beyond just getting bigger. But the Carnet system makes cell culture feasible and scalable, and the business model supports the above of onboarding of whole different stakeholders. So that's our take on scaling from technology point of view. Thank you very much, and thank you very much for the CMS21 organizers for this speaking opportunity. Thank you, and goodbye.